There are monsters in our universe so unimaginably massive that our own sun would barely register as a snack. These supermassive black holes pack the weight of billions of suns into a single point. The standard laws of physics demand that these giants start small. A dying star collapses, leaving behind a relatively tiny black hole. To reach a gargantuan scale, that tiny seed must spend an enormous amount of time gorging on surrounding gas and merging with others. It is a slow, agonizingly gradual process. In this framework, time is the ultimate currency. Extreme size requires extreme age. But that rule only holds until we peer back to the dawn of time. For that, we use the James Webb Space Telescope. This image represents a look deep into the early universe. In April 2026, Webb beamed back data from these regions that shattered our established timeline, revealing billion solar mass black holes existing just a few 100 million years after the Big Bang. Finding something this heavy so early in cosmic history is physically absurd. It was like finding a 6-foot-tall newborn baby. The math is uncompromising. The universe simply had not existed long enough for these objects to grow through normal feeding. This contradiction proves that either our timeline of cosmic history is flawed, or our understanding of gravity is missing a vital chapter. If these monsters didn't have billions of years to grow, they must have skipped the star phase entirely. Normally, massive clouds of primordial hydrogen gas cool down over time. As they cool, they fracture into thousands of smaller clumps, igniting into stars. But a new 2026 study by scientist Yash Agarwal identifies a mechanism that stops this normal cooling. The research suggests the answer lies in the invisible scaffolding of our universe, dark matter. To explain the giants we can see, we have to look at the invisible forces manipulating them from the shadows. In the dense conditions of the early universe, dark matter was highly unstable, decaying and emitting intense radiation. That radiation flooded the surrounding hydrogen. It pumped enough heat into the primordial clouds to keep them whole, stopping the gas from fracturing into stars. Without stars to form, the massive, unbroken cloud pooled together until its gravity became unbearable, caving in on itself. This is direct collapse, the birth of a supermassive black hole in an instant, bypassing billions of years of standard evolution. Decaying dark matter acted as a cosmic time jump, providing the exact secret shortcut that created these impossible cosmic giants. When we look at the distant galaxies in this deep field image, we are seeing the direct results of this rapid collapse. For decades, dark matter was viewed as a passive anchor, invisible weight that only provided extra gravity. This data reveals it as an active, radiant force that dictated the chemistry of the early cosmos. Dark matter stands as the secret architect behind the universe's most extreme anomalies. The April 2026 discovery forces us to redraw the accepted timeline of cosmic history from scratch. We now know the very first galaxies were anchored by monsters forged rapidly in the dark. This leaves an unsettling question. If an invisible, decaying force shaped the dawn of time, what else is hiding out there in the dark? The true history of our universe is still being uncovered. To keep exploring the unseen forces that govern the cosmos, subscribe and join us for the next mystery.